Hi, everyone. My name is Nicholas Savage. I work at a company called Millworks Custom Manufacturing. We're a local fabricator at Eglinton and Kiel. We've been working closely with many architects in the city for a very long time. There's a 20-year relationship with Diamond and Schmidt and KPMB that we're really very proud of. We've been working with Partisans since the very early days, another relationship we're really proud of, and also doing some really amazing work with InStudio. Literally, there are so many great architecture practices in the city. I can't name them all, but really we consider ourselves to be an architect design focused manufacturer. A lot of the problems that we talked about, that were talked about this morning, are exactly the kind of problems that I handle every day. I was really excited to hear a lot of what I see every day in my professional engagement being talked about before, God forbid, I even see it. So this is all good news as far as I'm concerned. One thing that I'll show you today or this afternoon is a shop. So let's take a quick look into our shop. You can see a couple of CNC machines here. We have 13 of these CNC machines. We have 200 and about 20,000 square feet of shop space at MCM. This is on the right, a movable bed CNC with 3 heads. On the left, you can see a 5-axis CNC. This machine on the left is actually the machine that we cut the bar and the sauna with. So we keep going, we can see we have a veneer department on the left. This is where we're doing all of our stitching and our pressing of veneer. Honestly, both in metal and in wood, 95% of this stuff is sheet goods. That's just based on how these commodities are produced and honestly, a kind of cost method. You can see on the right-hand side, 2 more of these CNC machines. We have all gantry style CNCs, not 50 feet long, unfortunately. All of these beds are about 5 by 10. 9 of them are 3-axis and 3 of them are 5-axis, which is really helpful. I'll keep going. On the left-hand side here, you can see Adam working away. This is one of our typical standard mill workspaces. Often people ask me, how do you manage 250 people in a fabrication space? My answer is 5 at a time. So when you work with MCM, you're gonna have a project manager. That project manager is gonna have a handful of team leaders. And so the communication is actually really easy from front end to back end. On the right-hand side, you can see our really wonderful upholstery space. They're working away, some patterns in the top here, really lovely thing to see. In addition, people don't often think about it, but finishing is a really important part of this world. This is an automatic UV spray line. You can see that this gentleman at the end is stacking panels that just came off the line, which is a really valuable thing if you're going to do large scale stuff. One thing that came up here all the time is cost. The biggest cost here is always in time. For some reason, time is always the thing that costs the most money. So whatever you can do to increase productivity, to get things out the door faster, is always beneficial. And those UV lines really help. So we're not just a woodworker, we're also a metal worker. You can see on the left-hand side here, we have 2 CO2 lasers. These lasers, they can cut up to 3/4 of an inch solid steel. Really lovely tool to have sitting just below your office. And again, just like in metal, just like in wood, the vast majority of this stuff is being done by what Patrick described as subtractive methods. The additive methods are just too cost prohibitive at the moment. This may and will change later on, but for the time being, most of the manufacturing is happening through subtractive means. We'll keep going. When the sort of these nets and these patterns come off of our laser, they go to something called a press brake. Here you can see the gentleman running our press brake, blends these things into panels. You'll see at the end a job we did with Diamond and Schmidt that's a panelization project that will have all been bent on a brake, just like you see here. On the right-hand side, you can see a typical welding station. You have 2 guys working away. Beside them, they have 2 helpers, 2 prep guys, and they are working away there. So let's start the first project. Now that you have an idea what a workshop looks like, this is a plan from Partisans of Bar Raval. It just goes to show the kind of information we get from them. One thing that's really interesting about Bar Raval is, and Partisans in general, and also what we encourage architects to do with us, is there's always an early conversation that occurs. So they ask, what are our material constraints? What do you think kind of materials are we going to use? What's the biggest panel you would recommend? What I really love about this slide is it shows that conversation really clearly. What Partisans is trying to tell me right here is, okay, you've told me about the size that a panel can be. So we're going to start to lay out all these panels and see what happens. What they're trying to convince me to do here is to align all the grain on this entire wall. And what I'm going to go back and say to them is that in some cases you have no problem on this large piece that's vertical here, and in some of the pieces over here you have no issues. But here where we have these long skinny panels where we have the grain at cross purposes to the length of the panel, I'm going to raise my hand and say, hey guys, you know, the wood is the most unstable. If you think of the wood as being made from a bunch of little straws bundled together, well, the actual area, the straw surface area is growing and shrinking, but the length of the straw is not growing and shrinking so much. Oh, sorry guys, somebody else's timer. And then, so what we then explain to them is that you're going to be really heavily doing this tool path cutting on these. We don't think the grain is going to be such an issue. So we actually convinced them to do all these panels long grain so that they would be more stable on site, less of a tendency to check. And then this is where we can kind of get involved to try to prevent any disasters from happening on a material science side. So there was a conversation, we managed to convince them, and then that's what we did. So what you can see here is the final model. One thing that I think is really interesting to recognize is there are small minor modeling changes that happen between this phase and this phase, which is to say they haven't stopped designing. They have something at this stage that is very much looks like a finished product, but it still isn't. The actual shapes and sizes of these pieces were actually allowed to be affected by the tool path patterns that happened over top of them. Just so for some background, all of this modeling was done in T-spline. It started as physical sketches, and then at 1-to-1 large-scale physical sketches that became modeled in Rhino as T-spline, and then a grasshopper script was laid over top in order to do these tool paths. One thing that I think is really interesting about this job is all of those tool paths are loops. So anytime that we had some issue with a single panel where the tool paths weren't working, in order for them to update just that panel, they had to update every single other panel on the entire job because the tool paths were all connected. The nightmare that this caused on the production side, you will have no idea, as well as the fact that one thing that's really interesting, you can see some of the original Sapelli that we purchased on the truck. And then you can see us starting to machine test patterns. Here is a really interesting slide because you can see when we our original intention, when you're holding this thing at 1-to-1, we were using a 1/2-inch bit on the left side. And it looked beautiful actually. At this scale, as you hold a single piece, it actually looks a bit nicer, but we realized that this thing is a lot bigger than a single piece you hold in your hand. So we actually moved to a 1-inch round bit that cut on these tool paths. And I'll explain quickly how this worked and what the biggest problems were. So here you can see us starting to cut a piece. We have on the right side a clearing bit, clearing away this material, and on the left side us doing these tool paths. One thing that's really neat, so you have to understand that they had already been through the entire sauna project when they got here. So they're always interested in not repeating what they've done before. So they had a carved wood project and now they have another carved wood project, and they said, listen, it has to be different. So the idea of integrating these tool paths was critical to the concept basically. And so what happens that's very different on tool path cutting versus regular 5-axis or 3-axis CNC cutting is that a CNC router typically cuts the same way a printer prints, which is to say line by line. So what each line is, we call a step over. Typically that step over is very, very small. If you don't want to see the actual tool paths, these straight tool paths on a CNC router, those step overs need to be about 1/2 millimeter. Anything beyond that, even a millimeter step over, you're going to see those lines. So here, those lines are the feature. What's really amazing about this is if you can imagine the number of paths I would have to do every 1/2 millimeter is actually substantially reduced by this tool path cutting. In some cases, I'm doing a tool path every 3/4 of an inch. And so that's obviously a lot less than every 1/2 millimeter. And so in theory, that speeds up the cutting and makes this less expensive to mill. Now, what we didn't understand at the time is that we were using Mastercam, which isn't an embedded system in our CNC machines, and that the level of complexity of the files themselves was creating a level of overturning. So we have a sort of a universal joint that has this 5-axis head on it, and the complexity of the panel was actually causing the head to overturn, to turn more than 340 degrees, whatever its maximum was, and it would uncork in the panel. like there was no protocol to stop what it was doing. The CNC machine just had a kind of mind of its own. So this was early days. I mean, still these things are well developed, but less in practical terms. So we had to work with a company that produces things called machine posts, which is a little if and or if or command that every time there's a problem, it's resolved sort of in a code level, at a code level piece by piece. We did about 20 revisions to our machine post before we were able to cut these, which is to say, you never really know where the problems are going to hit you. You can guess, but you're never really going to know. Ironically now, the systems and the programs are so much better that probably we wouldn't have to go through that again if we were to do this today, but you often can't choose when you do these things. You have to do them with the technology you have, not the technology you want. So as we keep going, you can see us starting to lay these out. You'll recognize here, do you see this straight line of the wood grain that runs the length of the panel? That was MCM's interjection and something that I would stand behind. And then if you go into this space, this is not the first thing you think about is the grain direction, God forbid. So it didn't turn out to be so critical and is part of the conversation that happens between the architects and designers. Here's a much younger me pretending to do some work. So yeah, made sure I got on camera for that one. And then this is the final product. I mean, one thing that I also really love about this project is that this is classic MCM, which is to say probably the most interesting thing is these toolpath panels. But for me, it's the least interesting thing because in a way they were just wallpaper. Very difficult to figure out what they were and how to make them. But once you figured it out, it was kind of over. A computer did most of the work. So the other things that we did in this space is all the walls behind the CNC panels are all acoustic panels produced by MCM. We did all of the bronze trim work. We did all of the solid furniture. We did all of the metal work. There's a very complicated stainless steel bar rail behind here. There are cast brass bar tops. There's a really interestingly made front door that's made in a traditional method with some modern tricks. It is the kind of mix of work that happens in Bar Reval that I'm really proud of, to be honest. Okay, we'll keep going. So here we have another project that was done by Diamond and Schmidt, and then this is what we saw on day one. So we see a series of images, and I believe at this point there'd already been a conversation, very minor, which is to say, based on what we want to accomplish, what do you think is the smallest hole and what do you think is the largest hole? So we had a kind of minor impact at this stage, but the method was already kind of dialed in. And let's talk a little bit about the method and how it changed. So this is a spec. So as a fabricator, I see a document like this and a document like this, and then I'm asked to send one of these crazy prices to the moon that we've been talking about. And then let's talk a little bit more about what it's talking about. We won't read through this whole thing. Basically what this tells me is they want to overlay two patterns, both halftone. One is a perf, one is an etch, and that the combination of these patterns is going to create a clear image of some landscape in Canada. So this second layer I found a little bit problematic, but we start to test. So you can see the Rhino script below. You can see on the left-hand side a halftone image. We had a ton of issues with the overlaying of two halftone patterns in terms of kind of like they were not overlaying nicely because they were both offset perfs. So how we decided to solve this issue, not to have any interferences, almost like moire effects in some way, was to make the second pattern stochastic. So with the issue with the stochastic pattern is it wasn't reading as clearly as the halftone pattern, but the beauty of the stochastic pattern is it wasn't causing any interference with the pattern behind because it was random. Now, we are testing methods to chemically etch, to physically etch, to all sorts of things. Meanwhile, I am a kind of Occam's razor guy, and then we are producing panels as halftone only. Basically, my goal was to do at least one thing on this project perfectly, and so I focused in on making sure that these halftone patterns, I learned that the density and the space between the holes was really the only thing that mattered. So my job was to take a panel and figure out how to get as many holes into it as possible. So we started at around 500 and we ended up getting about 900 holes a square foot, and the density was critical to the clarity of the image. This is a one-to-one printout. This printout was a result of the fact that typically when we tender something, we do like a 3-foot by 3-foot sample, and the client could not read these images. They didn't understand what they were looking at. And so we actually physically, once the patterns were approved by Diamond and Schmidt, we printed them out at 1-to-1 and invited the client to come and review them in person. So you can see what we start to do here. You can see an original panel that's been punched on a turret punch. We had 3 options for punching these. We could either do this with a laser or a water jet or a punch. When we decided to make these from brass, the brass is too reflective for the laser, so we were left with either water jet or punching. The water jet took too long, so we did the punching. You can see the issue with the punching is that it deforms the panels, so we had to add in an extra step to undeform the panels before we went to punching. Again, nobody priced out this intermediate step of sending it to the rollers. It just happens. You just have to sort it out. So then we get them rolled, we get them straight again, and we get them sorted out. So on the right, you can see a couple tests against the paper. Here you can see a bit more of our process. We're patinaing, we're brushing. This was all because there was such a desire for consistency that typically what you're doing with these bronze panels is hand brushing them. Wasn't working for consistency, so we bought a whole new machine and developed a process to do a kind of mechanized brushing to get color consistency. And then this is the finished product. So again, really wonderful, sort of a one note. Like from our perspective, there's this 12-year job that has been living with Diamond and Schmidt for eons, and then we get to come in the last year and make some of the prettiest stuff. So we're really, really thankful for the opportunity to work on a job like this. And you're really constrained, like you need to perform. So one thing that was really interesting is this was done as a design assist. So the pattern was not sorted when it came to me. We actually developed the Rhino script and worked alongside the design team at Diamond and Schmidt. A guy named Dieter Tevz and also Martin Davidson were really, really keyed in on the pattern. Chris Hughes also happened a ton, was running the job basically, but then there was a lot of collaboration between MCM and the designers to make sure that this was right, and we're really happy with the result. And then that's it for me.